Hi, today we are going to talk about Internet of Things for next generation smart systems, a review of current challenges, future trends and prospects for emerging 5G IoT scenarios. Here is our outline. First, introduction and background. Second, motivation and overview. Third, artificial intelligence driven use cases for 5G IoT networks. Fourth, challenges and issues. Fifth, conclusion. And finally, critical of the paper. Momentous developments in wireless sensor networks, telecommunications, and informatics have paved the realization of pervasive intelligence, which envisions the future Internet of Things, which is also called IoT for short. Currently, the IoT is envisaged both at the individual and the professional level. For an individual, IoT plays an important role in enhancing living standards in the form of e-health, smartphone, and smart learning. For a professional, IoT funds the application in automation, smart supply chain, and transportation, remote monitoring, and logistics. Recent trends shows researchers' huge interest towards the combination of various technologies, such as integration of sensors and embedded systems with cyber-physical systems, device-to-device communication, and 5G wireless system with IoT as a center. Currently, new business model set for IoT implementation requires massive connectivity, high privacy and security, complete coverage, ultra high reliability, and ultra low latency. The trending 5G enabled IoT encompasses increased data rates, better coverage, and high throughput, hence providing solutions to business model and enabling IoT to robots, actuators, and drones. According to Cisco, there will be 500 million devices connected to the Internet by the year of 2030. Hence, the $1.7 trillion is also expected as expenditure on IoT by 2020, as per International Data Corporation. IoT refers to the things or devices and sensors that are smart, uniquely addressable, based on their communication protocol and are adaptable and autonomous with inherent security. There are three components that form the basic of IoT architecture. First, hardware. It comprises of sensor nodes, its embedded communication, and the interfacing circuitry. Second, middleware. It comprises of data storage, analytics, and handling resources. Third, presentation layer. It comprises of efficient visualization tools that are compatible with various platforms for different applications and presents the data to end user in an understandable way. The parameters affecting the architecture of IoT are manifold, so current research efforts have been made to devise the most optimized architecture that handles network issues such as scalability, security, addressability, and efficient energy utilization. As for the future, the number of devices connected to the network will increase. Research is carried out in solving the scalability issues by developing various multi-hop routing protocols covering a larger area and self-adapting. These fall into three domains: data-centric, location-based, and hierarchical.
With respect to IoT, we find that it is integrated. With respect to IoT, we find that it is integratable into many different fields and disciplines. This is because IoT is in and of itself interdisciplinary, combining business, science, engineering, and humanities. This allows for the realization of efficient and resourceful research opportunities to investigators in many different fields. Additionally, we find that IoT is very easy to integrate into broader society. It also has the promise to transform our world into a smart world where everything is more easily accessible, requiring less time and effort. We have seen this in many different countries, such as Brazil, China, Canada, and the United Arab Emirates, who have all experienced advances in urbanization, infrastructure, growth, economic sustainability, and citizens' health and services as a direct result of the incorporation of IoT into their societies. In addition to its integration into broader society, the integration of IoT into the private sector has led enterprises to not only meet but exceed their business needs. For example, the Bank of Cordoba has implemented an IoT-based video solution and has seen increases in their productivity while enabling marketing efficiency and security. Additionally, IoT has also seen implementation into current technology in order to make them smart. An example of such an implementation is the incorporation of IoT into cars in order to create smart cars. Additionally, we've seen other trends in IoT, such as the concept of the smart environment, which has, again, been successfully implemented. We've also seen some smaller concepts within the smart environment, such as the autonomous car, passenger counting in logistics and transportation, and mobile ticketing, which have already been fully implemented as smart environment concepts. Additionally, improvement of these technologies is continuous. Futuristic applications such as the robot taxi is currently underway.
Hello, my name is John Serrano, and I will be talking about the vision and development of 5G-enabled IoT. To start off, we should talk about the requirements of 5G IoT. Some of the requirements of 5G include utilizing low band, mid band, and high band spectrums. What this means is being able to utilize spectrums that run on 6 gigahertz frequencies or below, or spectrums that run on 24 gigahertz frequencies or above. And then also another key feature of 5G is to have high throughput and low latency. So we want to be able to service multiple devices at the same time while having a relatively short period of time of servicing said devices. Now, when it comes to meeting these requirements, these can be hard to do. There are in many ways that we are still struggling a bit with how to actually meet the requirements that were set for 5G. And some of the issues that pop up when meeting some of these requirements are because 5G requires so much more throughput than 4G. It requires more antennas to process all the more devices that we want it to, and these more antennas that we need can increase the amount of interference that's coming between them from the antennas themselves and the devices receiving them. So this is one of the problems that 5G faces. Another thing that it faces is the size of the signals. We use millimeter wave signals, and these signals can be absorbed by the atmosphere. Noise like rain can interrupt these signals. So this also weakens 5G's capacity to some degree. And obviously, we would like to prevent that, if at all possible. Moving on to the next slide. In order for 5G to meet the current standards that are specified of it, technology is being developed, and new emerging technology is also being used to help 5G meet these requirements. It should be noted that many of these technologies would be either incorporated into base stations. So the base station basically serves as a central hub for 5G mobile networks. Effectively, what it can do is it is responsible for sending out signals to the cellular devices, to receiving from cellular devices, And it can also send and receive to other base stations, and it can basically be used as a power amplifier. Base stations can also come into different sizes. These sizes are typically called cells. They can become in millimeters to picometers. So they come in a broad spectrum. And this will become important later. So now some of the technologies that are being used in 5G networks are massive multiple input, multiple output. With massive multiple input, multiple output, this allows a base station to send and receive multiple signals simultaneously. So this would rectify the throughput requirement that would be expected of 5G mobile networks, and it would just allow base stations to be able to send and receive multiple signals to multiple devices and even other base stations all at the same time. In addition to this, would also include beamforming technologies, and in much the same way, beamforming technologies, especially with the use of BDMA, so this would be beam division multiple access, and effectively what the beam division or beamforming techniques include, they send a small wireless signal that targets a specific device. And with beam division, these specific beams can be split up, and they can either target, multiple beams can target the same device, or even be split up to target other devices as well. And the big thing about beam techniques is they could be a very useful tool in removing the interference issue that we would have with the increased throughput and increased number of antennas that 5G would require. Next up, we have heterogeneous networks, and heterogeneous networks effectively aim to curb power consumption as well as throughput and latency by having multiple base stations, cells of varying sizes. So from picometers to millimeters. And these different base stations would basically serve as a network to promote data transmission. And it would help significantly reduce the power consumption that would be required of 5G cellular networks as a whole, which is something that 5G networks definitely strive for. Another such emerging technology is CRAN, and Centralized Radio Access Network, and it is also a technology that is used to try to reduce the power consumption of 5G. Specifically, what it does is it proposes splitting up the radio component and the cloud component of a base station into separate areas. So it would reduce the power consumption needed, as you wouldn't have one single device trying to multi-manage both of these factors. And additionally, you would be reducing the complexity overall, as again, they would be separated. And these are just some of the technologies that are being used. to try to help 5G and build 5G closer to what its intended vision is, and especially with the field of IoT in general.
Artificial intelligence driven use cases for 5G, Internet of Things networks. The higher data rates possible in 5G IoT makes it possible for the implementation of data-hungry and computation-intensive artificial intelligence algorithms for various users' applications, such as virtual speech recognition and video classification. Some current and futuristic AI-based applications that could support it over the 5G are big data processing enhancement. The 5G intelligent IoT has the potential to tackle problems related to communication channels congestions and enormous data processing. The latest techniques practiced on IoT and the reliable and fast speed of 5G networks incubates the environment of creating applications such as utilizing big data to its maximum potential, such natural language processing, face recognition, etc. Smart transportation systems. Vehicles with continuous connectivity are becoming a reality with integration of 5G with IoT. This integration has given the ability to access the internet in more efficient ways. Researches have been performed regarding a self-driven vehicle with the use of connecting to the internet. A smart transportation system can provide communication between the smartphone of a passenger and the vehicle itself, just like other IoT devices. A smart transportation system can also provide new features for more control. Utilizing abundant data of interconnected IoT devices. The huge data generated for continuous connectivity of IoT based devices with 5G can be used in the prediction of accidents and crimes by correlating the available huge data. The extraction of real-time data is possible with the help of IoT. This has allowed devices to be controlled in various ways without much human interaction. For example, it is reported that by detecting damaged pipes and fixing them, the Department of Park Management in Miami, USA, has saved about $1 million on their water bills. The integration of 5G with IoT and AI has a huge impact on businesses by making predictions using available data and making control decisions for enhancing the technology to improve quality of life. Architectural scenario where 5G meets artificial intelligence. As we can see on this graph, we have different IoT devices on the left bottom corner. These smart homes, grid transportation, buildings, and other devices can send huge amounts of data over the 5G network. Then this data is utilized and processed using artificial intelligence to create applications such as augmented reality, virtual reality, and holograms. Challenges and issues. Current trends show that the future 5G IoT network should be capable of supporting the massive connectivity of devices by performing high and consistent quality of service. Can 5G find the balance between ease of connectivity and security? The arbitrary connection of cellular phone devices to the network gives rise to security-related issues, such as interception of data flowing in a network and incorporation of unauthorized codes to unofficially control the network services. There should be an association, joint effort, and coordination to strengthen the security. The implementation of secure boot and reliable execution environments contribute to the security of intelligent devices, which protects them from illegal environments of other devices. A combination of intelligent systems and security of software will not only strengthen the safety communication of interconnected IoT devices, but also motivates novel approaches for upcoming wireless communication networks. Is 5G flexible enough to facilitate different types of network configurations? The traffic generated by such IoTs is different from that generated by cellular systems in many aspects. IoT devices are limited in energy and computation resources. These IoT devices' characteristics make their access to 5G systems different from classical cellular devices. Identifying the right system parameter configuration for the specific IoT use case is a big challenge. Will 5G be future-proof? Coverage enhancement is one of the primary challenging physical layer objectives to improve the maximum coupling required to support tactical internet and multimedia applications. Security, privacy, energy efficiency, and massive connectivity are other major concerns. Hence, research efforts are being actively pursued by researchers in each domain. Nowadays, deep learning is applied to IoT and mobile applications for implementing real-time or near real-time data processing tasks. Considering the limited performance of data transfer networks, transmitting massive data to cloud for deep learning will consume much energy and produce much transmission delay, which reduces the efficiency of deep learning tasks. The challenge of the cloud-centric system was considered, and an autonomous and incremental computing framework and architecture for deep learning-based IoT applications was proposed to tackle it.
Conclusions. This paper gives an introduction and some background knowledge of IoT. Then it gives a detailed review of the 5G wireless technologies. It reviews the evolution of cellular wireless technologies and talk about various architectural components of the 5G networks, especially mentioning the key improvement to the physical and network layer of 5G networks over its predecessors. And then it discussed some modern-day applications running on top of 5G IoT. For example, smart transport, smart healthcare, and so on. And at the end of the paper, it talks about some challenges. The QoS requirements in modern 5G IoT, whose traffic characteristics are significantly different from other traditional 5G network applications, mainly in the uplink direction rather than the downlink. And another challenge is the standardization issues due to several heterogeneous nodes participating in the 5G IoT network headnets. The critique of the paper. This paper is a review. We should obtain from it the author's understanding, organizing, comprehensive analysis, and evaluation of many literatures in a certain field during the writing period. It means that the author should summarize and synthesize the work that has been done by predecessors in this direction, understand the current research level, analyze the existing problem, and point out possible research problem and development directions. Let's talk about the good part of the paper first. This paper is well structured. We can see from it that the author's logic is clear. First, the author summarized the content of the paper in the introduction and lists the discussion content of each session. This helped the reader to have a basic understanding of the paper. Then the author first summarized and synthesized the work that predecessors have done in the direction of IoT and discussed the current situation, opportunities, and prospects of IoT. Then it summarized and synthesized the work done by predecessors in the direction of cellular wireless technology, discussed the current research level of 5G, and point out how 5G technology can improve the predecessor technology to make ubiquitous development of IoT possible. Then the development direction of 5G IoT is pointed out through examples. Finally, the challenges and problems of 5G are analyzed. We can see that this paper satisfies the requirements of a review. And the authors make a good use of tables and figures. We can see that the author used a lot of tables, figures, or diagrams in the paper. Compared with long text, tables and figures can express the author's meaning more clearly, especially what needs to be compared. The shortcoming of the paper. The content of the paper is different from what I expect. According to the title of the paper, I think the center of this paper is the IoT, so I hope to see more content about IoT or 5G IoT. But I think this paper is more focused on 5G, especially in the part of vision and development of 5G-enabled IoT from 5G cellular technologies. I think the description of some features or concepts adopted by 5G technology to support 5G IoT are too detailed. And at the end of the paper, the challenges and problems mentioned by the authors are more specific to 5G. If I am the author, I will learn more about the difference between 5G IoT and earlier IoT. In what ways the development of 5G have helped the development of IoT, and the problem encountered by previous IoT, which are solved or improved due to 5G, and give some examples. Then it will raise the challenges and problems currently encountered by 5G IoT and whether there are potential solutions. And I expect to see more authors' own opinions. A review is critical, so it is necessary to summarize and review the literatures with the author's own critical thinking, rather than just stacking academic research. I don't think the authors give enough of their own opinions on 5G IoT in this paper. I can only see from the paper that the authors are very optimistic about the prospect of 5G IoT. However, the applications of some 5G technologies or IoT technologies is only briefly described, and no further discussion is given. I think this paper should give more examples of 5G IoT applications, then discuss their advantage and disadvantage, and propose a potential direction of further research.